So last class we talked about and learned about variation, and that tends to be a challenge for Unit 4, one of the most challenging topics. So we're going to go ahead and review that today. We're going to review everything, but the majority of our time will be spent reviewing variation. So just a quick overview of other topics that we've done so far. Functions, domain, and range are one. So looking at this graph, I can tell that it is a function because if I run vertical lines through my graph, it only is touching one point at a time. As far as the domain goes, well, notice that this is a U shape and it goes off the graph, so we can assume that it keeps going. And as I mentioned a couple classes ago, this U shape always has the same domain and the same set interval notation for the domain. It keeps going to the left forever, so it's going to negative infinity, and then it keeps going to the right forever, so that goes to positive infinity. And in set notation, this is something that's worth memorizing because it never changes, x such that x is all real numbers. So it's saying that my x values include all my real numbers. For the range, I'm going to go to the lowest y value, the lowest point of my graph, which happens to be at 4, included because it's a solid line there. And then my graph shoots up forever, so it's going to positive infinity. In set notation, we go y such that y is somehow related to -4. And I'm going to go with y is always greater than -4. It's always above -4 or equal to, because we're including -4 as a possible y value. Next, let's look at function notation. So we're going to evaluate f of 1 and f of -1 using this graph up here. So it wants to know, well, when x is 1, what is my y value? Well, let's go to next value of 1. What is the y value there? Well, the y value would be 0. So it's f of 1 and 0. You can write the word pair 1, 0. And again, going over to -1, my x value of -1, follow that down to your graph, and that's the point -1, and what's the y value there? Well, that's going to be -4. So there you go, -1, -4. Next, we're going to evaluate function notation from an equation. So I'm going to replace x with -2. 2 times -2 squared minus 3. First, do your parentheses, your exponent, so that's +4. -2 squared is always +4. And then 2 times 4 is 8. 8 minus 3 is going to be 5. So you could write -2, 5, the ordered pair as your answer. And then plugging in +2 for x. I actually expect to get the same thing, because when I square 2, it doesn't matter if I'm squaring +2 or -2, I'm going to end up with the same value. So this gives me, again, 5. So g of 2 equals 5. Oh, and we missed something over here on number 2. It says find x when f of x equals 5. So we're going to go back to our graph where we have a y value of 5. So that's going to be right here. Follow it over to your graph. So we know the y value is 5. Well, what is the x value there? That would be 2. So you can say x equals, x equals 2. Or the ordered pair 2. Alright, back to number 3. So again, we're kind of doing a similar thing, but with an equation rather than a graph. It says find x when f of x equals 15. So I'm going to take my function, 2x squared minus 3, and I'm going to set that equal to 15. So add 3, we're just going to solve, add 3. So we'll get 2x squared equals 18, divide by 2, divide by 2, so x squared equals 9. Well, if x squared equals 9, then what's the opposite of that? Well, square root of 9 would be 3. So x equals 3. Take a look at slope. So remember, we've got a couple equations that we utilize for slope. One is rise over run when we're looking at a graph. So our 2 points are actually picked for us. So we're going to go, okay, well, what did we rise? We rose up 2, and then we went left 1. So be careful there. That means you need to assign a negative, which makes the slope -2. 2 over -1 is -2. If you're looking at problems like 5, 6, and 7, we're going to use our slope formula, y2 minus y1 over x2 minus x1. So go ahead and plug in 11 minus 1 over 10 minus -16. But minus negative, I always want to make that a plus right away. So that gives me 10 over 26. Always look to simplify, and if you put that in your calculator, math enter, you should simplify it to 5 over 13. Let's do number 6. So again, plugging in -9 minus 16 over -7 minus -7. So make that a plus. That gives me -25 over 0. No, you cannot have a 0 in the denominator. That means that the slope is undefined. UND, as we like to simplify it. Undefined would be a vertical line, a Buck's line. Let's try number 7. So we're going to do -3 minus -3, which makes that plus, over 7 minus -14. This also makes that a plus. So that gives me 0 over 21. And remember, 0 on top is okay. That's just equal to 0. So that would be a horizontal line with a 0 slope. Next, if you look at 8 through 10, we're going to have to think of slope in the format of y equals mx plus b, where m is the slope. So this is already in that format, so I can just tell what m is by the number in front of x. So here m is -2. Now be careful, when we get to number 9, you can't just tell the slope from looking at the number in front of x, because I have to first put it in slope-intercept form. I'm going to start by subtracting 4x on both sides, which will give me -8y is equal to -4x plus 16. Divide both sides by the coefficient in front of y, and simplify. So that gives me y equals 1/2 x minus 2. So my slope is going to be 1/2. We're in front of x. Uh-oh, what's going on with number 10? What the hoy bucks? It's a hoy line because it's just y equals, there's no x. So that tells me that the slope is 0. Just a horizontal line. Again, feel free to pause and go back if you need to hear it again. Next, we're going to look at variation. So what direct variation is it's when one variable y varies directly as x, or vice versa. So the formula would be y equals kx, and that's super important to have memorized and have added to your formula sheet. K is the constant of variation. So as x gets larger, y should get larger. Or as x gets smaller, y should get smaller. So we're moving in the same direction. Either both go up or both go down. And remember that a line, a direct variation line, has to have a y-intercept of 0. So remember, our line has to go through the origin. Kind of missed it, but it has to go through the origin in order to be direct variation. Some real-world examples, we see direct variation all the time. Fruit sold by the pound, if you think about it, if you buy 2 pounds of fruit, well, that's going to be the same cost per pound, so you're going to be multiplying times the constant, okay? And then distance traveled by a car over time, as you travel more miles, you're going to spend more time. If you travel less miles, you're going to spend less time. So it's moving in the same direction, okay? And then you can also think of circumference of a circle varies directly as the diameter. As the diameter increases, so does the circumference of the circle. And then wages is my favorite example. Think about it. If you work 0 hours, say you work a tropical smoothie, if you work 0 hours, you make $0. But if you work more hours, you get more money. If you work less hours, you get less money. So maybe you can think of a couple others as well. So 11 says, if you buy 3 pounds of grapes at $6 per pound, how much would you pay for the grapes? Well, if we're buying 3 pounds, $6 per pound, we're going to multiply. So 3 times 6 is going to give me 18. So that's going to be $18. And that's actually not surprising. If you've ever been to the grocery store with your parents, grapes are really expensive, which is why I never buy them. So again, that would cost $18. So what's the constant? And what are the two variables? Well, I would say one of the variables is the number of, or the pounds, number of pounds of grapes. And then the other, the dependent variable would be the cost. So then what's the constant? Well, the constant is how much are the grapes per pound? Well, think about it. If you spent $6 for 3, how much was it for each one? Well, we're going to divide, think about it, y over x, which is our formula, and we're going to get that the grapes are $2 per pound. So if I wanted to say, well, I'm having a huge, I don't know, bridal shower, baby shower, I need to get a ton of grapes, I'm going to get 12 pounds. Well, how much would I spend? We can use the same constant and go, okay, well, 12 times 2 is going to cost $24. Maybe I want to get blueberries instead. So how can you write this as a linear equation? Remember that direct variation is y equals kx. Well, we know that k is 2. The constant is $2 per pound. So y equals 2x. All right. Look at 12. It says the data that represents direct variation. The way to find what the constant is, we just kind of saw this, is y divided by x for direct. So I'm going to take each pair, except for 0, 0, and you can divide 3 over -1 would be -3. 6 over -2 would be -3. -12 over 4 would be -3. So what's the constant? -3. And then you write your equation. Remember, that's y equals kx. And the constant is -3. It's going to be y equals -3x. So 13 says, if y varies directly as x, and x is 10 and y equals 9, what is y? Okay, let's forget about that for a second. Let's just find the constant. If it varies directly, I know the constant is y over x. So I'm going to give 9 over 10. And that can be simplified. So let's write our equation, y equals 9 over 10x. Now we can answer this question. What is y when x equals 4? So let's replace x with 4 and multiply. So we would get 18 over 5. Yep, 18 over 5. All right, well that's not super fun because it has no context. So let's read 14. So a refund you get varies directly as the number of cans you recycle. When I see a sentence like this and it's direct, I know that it goes whatever they say first R equals K times whatever they say second. So K times, I guess, C number of cans. So if you get $3.75 for 75 cans, how much would you receive for 500 cans? So we're going to use this pair that goes together to first find my constant. How much am I going to get per can? So replace R, the refund, with $3.75. This time we're looking for K. And replace C with the number of cans. And then divide both sides by 75. You might have to use your calculators here, I know that I do. And you would get 0.05. So 5 cents per can. Maybe you want to be collecting something else to get money. That's not very much. And now we can set up our equation, y equals 0.05x. And it wants us to figure out Well, how much would you receive if you got 500 cans? So let's go ahead and plug in, oops, I changed my variables. That really should be R equals 0.05 C. And so I'm going to replace C with 500. So what is 0.05 times 500? $25. So we get a refund of $25. Is it worth it? I'm not sure, but you know, if it's just you putting a recycling bin in your house and you guys drink a lot of soda, you know, maybe you should collect them and you can make some money that way. Anyway, let's change gears and look at inverse variation. So it's the opposite. Y varies inversely as x, or y is inversely proportional to x. And there's two super important equations. The first is y equals k divided by x, or to find the constant, you would multiply x times y. I actually don't want to fill in this sentence because it's not always true, so this is incorrect. Essentially, though, in order to determine its inverse, you're going to have a boomerang graph. So you're going to have like two boomerang shapes, either in the first and third quadrants, or in the second and fourth quadrants. So you should never cross your axes. Number 15 says, Boyle's law of gases is a real-world example of inverse variation. Likewise, for a trip to Myrtle Beach, the greater your car's speed, the less time it would take you to get there. So they move inversely. So greater the speed, the less time it would take to get there. Versus, remember, direct, it moves the same direction. So let's just take a look at our table that represents inverse variation. To find the constant, we multiply x times y. So 3 times 4 would be 12. 2 times 6 would be 12. 9 times 4/3 would be 12. 10 times 6 fifths, 12. And 1 times 12, 12. So what's the constant? 12. Now we go to our y equals equation and put k over x. So the last problem here says if y varies inversely as x, so inverse, and x equals 3 when y equals 9, then what is x when y equals 27? So first thing I want to do is find k. So k is whatever x times y is. So in this case, k is 3 times 9, which is 27. So there's your k. Now write your equation, y equals 27 over x. And it wants to know, well, what is x when y equals 27? So I'm going to replace y with 27. Remember, that's your equation. And I'm going to solve for x, which is interesting, because in order to solve for x, I actually have to start by multiplying x to both sides to get it out of the denominator. So I end up with 27x equals 27. And now, I divide both sides by 27, and I will find that x equals 1 when y equals 27. So there's really not much you can do with direct and inverse variation. Here are the key points. Direct is y equals kx. To find the constant, we divide y over x. Inverse is y equals k over x, and to find k, we multiply x times y. So those are the highlights, and really you're just writing the equation or finding k. There's not much to it. So keep practicing, and you'll just get better and better at it. Thanks for listening.